So this video is going to introduce our next chapter on Newton's laws and forces, okay, which is really fascinating. And one of the things that I really want to look at, though, is we're going to kind of talk about the history of this, okay. And so the first thing to look at comes even before Newton. There was an investigation into just how things move, and there was a thought experiment proposed by Galileo. It might have been something that came from some before them. But if you have kind of like a set of ramps like this next to each other, if you were to put a ball here and roll it, it's going to roll back up and come up back to the same height on the other side, or maybe just below. It's going to roll back and roll back and roll back, and eventually it'll slow to a stop because of friction. But if there was no friction, it just keep going back and forth. And you said, okay, well, if I make the other side a little bit more gradual, well, the same thing's going to happen, but it's not going to stop here. It's going to go a little bit further and go up to here on the other side, and go right back and forth between those places. And so he with this train of logic, he said, well, if I go like this and just completely remove the other ramp and let the ball roll down, since it's never going to get back up to that height, it's just going to keep rolling forever. Okay, this is what Galileo said. And he basically explained this as it's going to roll down and keep going forever unless something causes it to stop. Okay, and the thing that he said would cause it to stop is friction, which is what does cause it to stop. Because if you had a ball on a ramp and you rolled it down, it is going to stop because of friction, but ideally it would roll forever if there was no friction. Okay, and so this concept, this idea that things are just going to keep going like this, was picked up by Newton, who wrote a whole book, and this is considered to be Newton's first law. Okay, he kind of took it a little bit further, and he said that all objects want to continue moving at a constant speed when the forces on them are balanced. Okay, so this ball, when it's rolling along here, has two forces acting on it. Okay, it has its weight pulling it down, and it has a normal force from the surface here pushing up on it. Okay, normal force is the name of a force that happens when two surfaces are in contact. If you were to imagine what it looks like in a very, very tiny molecular scale, you could imagine that there's lots of little molecules that are pushing, whose nuclei are pushing against each other because they're positively charged. Okay, and so if you have a whole bunch of them, then the interaction of these surfaces, all these nuclei pushing against each other, repelling each other. Okay, and this is why things push against each other, and this is why objects have structure, because of these bonds between these things and repelling other things. Okay, so anyway, we have these balanced forces, and in the presence of balanced forces, things will continue to always move at a constant speed. This is Newton's first law. Okay, so that his law is basically that in the presence of balanced forces, things have a constant speed. So that's true of things that are at rest. Okay, so if this is at rest, it's going to stay at this constant speed of 0. If we have something sliding along, okay, let's say it's got a velocity of 3 meters per second, it's going to keep that velocity forever unless something makes that change. Okay, and so the name that we have for this concept is inertia. Okay, and so inertia is basically the property of objects. This is how we describe this property. This is what we call this idea that objects want to keep moving in a straight line. Okay, and we could even say that inertia is the measurement of this, because some objects, if you could imagine like a semi-truck, want to keep moving in a straight line more than other objects, like a little toy car. Okay, you would much rather be stuck in front of a little toy car coming at you, or let's say there was like a runaway toy car rolling down the driveway into the street. It would be easier to run out and stop that little toy car than it would be if there was a giant semi-truck rolling down the street. You wouldn't be able to stop that. And so the difference is that the semi-truck has more inertia. It's much more difficult to stop, okay? And so the inertia is kind of a measurement of that, okay? And so that's Newton's first law, and that's really, really important. And we're going to look at a couple examples of this. So Newton's first law suggests that an object in motion will stay in motion, and an object at rest stays at rest unless an unbalanced force acts on it. Okay, so this is a great example. If you've ridden a bike, you might have experienced this too. So this person has inertia, and they were moving at a constant speed, and their body wants to continue moving at a constant speed. Okay, so that's a great example of inertia. Okay, as I was saying, this truck here has more inertia. Okay, so think of a boat, very, very massive, has lots and lots of inertia, and so it can't even turn itself because it has so much mass. At least it can't turn itself very quickly, so it needs the help of these little boats so that it can keep turning. Okay, and so we have a couple of just little comic strips here for you to look at. Okay, so this is again an example of inertia. Okay, he is at rest, and his body wants to continue staying at rest. Okay, when you're in a car going around a turn, you might notice that your body wants to keep going in a straight line, and the car is going to kind of turn from underneath you, and that's why you feel yourself kind of getting pushed against the side. Here's another great one. Okay, this truck has much more inertia, has lots and lots of inertia. It does not want to stop moving. And one way to think about inertia is like whether something is easy to throw or not. So much easier to throw a pillow than it is to throw a car's battery. Okay, a car's battery has lots of inertia, a pillow does not. Okay, so a stone has lots and lots of inertia. If you think of a really heavy stone, it's really hard to shake it. If you were to be floating in space where gravity's not pulling it down the same way, it would still be really hard to shake because it has so much inertia. Okay, you wouldn't be able to shake it any more than you would be able to on Earth. Okay, and then here's another thing to think of. So thankfully, because of inertia, if you're sitting in an airplane and you step into the aisle, you don't fly straight to the back, right? You don't get tossed to the back of the airplane. You're going to keep going at the same speed as the airplane because you're moving at a constant speed and all the forces on you are balanced. Okay? And so we're going to go ahead and wrap this video up here. This is Newton's first law, the law of inertia. Okay? That things want to keep moving at a constant speed unless forces acting on them are unbalanced. Okay? So, yeah, we'll wrap it up here.